So when we're talking about solutions, one of the things that we talk about is solubility. And there are quantitative ways to describe solubility as well as qualitative ways. So when we're talking about a quantitative description, we're talking about using numbers. And so in terms of solubility, this first one here on the slide, this is a quantitative description. And so if you just look at it with me, it says it's the amount of solute that's dissolving in a specific amount of solvent at a given temperature. Now, temperature is referenced because the amount of solute that can dissolve may change with temperature. So when they're talking about solubility, temperature is referenced because it's an important part of how much will dissolve. So in this particular example, it says that 27 grams potassium bromide is dissolved in 100 grams of water at 23 degrees Celsius. So this right here, that is the solubility of potassium bromide at 23 degrees. So we know that up to 27 degrees, 27 grams, potassium bromide would dissolve. Okay, so that's quantitative. It tells us how much can dissolve. And we'll talk a little bit more about that on the next slide, the how much. Now we also can have qualitative descriptions. And qualitative descriptions use words to tell us what's happening or what we observe. And so in terms of solubility, we talk about the words soluble and insoluble, for example, or miscible and immiscible. So when you are mixing solids in a liquid, qualitatively we'll see that the solid either dissolves or it doesn't. So if the solute dissolves, we describe that as being soluble. And if it does not dissolve, we describe that as being insoluble. So again, it's not quantitative because I'm not telling you how much I added or even the temperature. It would just be simply saying that when these two things are mixed, they did or did not dissolve. Now, liquids, when you're mixing them with other liquids, there's different words that we use that have similar meanings. Miscible would mean the two liquids mix completely. So, for example, water and alcohols will mix completely, or some alcohols will mix completely, so we would say those are miscible. Like water and ethanol will mix. Water and oil don't mix, so we would say that those two liquids are immiscible. So in a way, miscible is similar to being soluble, and immiscible would be similar to being insoluble. So on this page, you need to know that there could be quantitative or qualitative descriptions for solubility. You need to know the qualitative words that we use, like what they mean. So if it says something is soluble, you need to know that that means it has dissolved or mixed with that liquid. And then you need to know that solubility really is a quantitative description. It will tell us how much of a solute will dissolve in a given amount of solvent. And we're going to use that in a couple slides. We're going to use that in a problem, like how would we use it? And we'll do that in just a little bit. So more vocabulary, there's three more vocabulary words that we need to be familiar with when we're talking about solutions and solubility. There's saturated and unsaturated. So I always think to myself, like, what does saturated mean? Like outside chemistry and what we're talking about at this moment, I would describe something saturated as being like completely full. Like you could have a rag and you could say, oh, it is saturated with water. Or you leave a cushion outside in the rain and you go to pick it up and you're like, oh my goodness, this cushion is saturated, which just means it's completely full of, my two descriptions of water or the liquid, like it's full. It can't hold anymore. And so that's what saturated means with solutions. A saturated solution means that it has reached its limit for how much solute it can dissolve. So in the previous example on the previous page, the solubility of the potassium bromide was 27 grams in 100 milliliters of water. If I added 27 grams, that solution would be saturated. If I added 28 grams, more than the max, it would still be saturated. And if I add more than the solubility limit, anything extra settles to the bottom. I'm going to write that down, because that's what we would expect. If it was a liquid, I suppose what could happen, if there was a limit with the liquid, instead of settling, it would form a layer, depending on its density, whether it would be on top or on the bottom. So saturated solutions mean you've added the limit or even more than the limit. And if you go above the limit, extra solid settles out. Now you might just notice this bullet point, it says that it's still a dynamic process. So it's not like if you saturate the solution, the solvent doesn't keep trying to dissolve the solute. The solvent will keep trying to dissolve the solute, but since it's full, it's like a revolving door. So it might dissolve some more, which would then force other parts to be precipitate out or turn back into a solid. So it's like having a full room, and if you let someone in the front door, you have to push someone out the back door because you can only have so many people in the room. So if you let someone in, someone has to go out. And the same for the solution. If you're at the max, there's only so much solute. So as the solution tries to continue to dissolve some, then it has to release some that's already dissolved. So it really is a dynamic or continuous process. It's not static. It doesn't just stop. Now, so that's saturated. I said that kind of weird because then I wanted to say, okay, but down here, unsaturated. So that means it's not saturated. So a solution that's not saturated means it's below the limit. You have less than the maximum, right? So in my previous example, the previous slide, 27 grams was the limit. So if I added 10 grams, I would be unsaturated. 15 grams, unsaturated. 26 grams, unsaturated. So anything below the maximum is called an unsaturated solution, and it would still have room for more. In lab, when we're qualitatively trying to decide if a solute is soluble or insoluble, we always try to work with unsaturated solutions because we want to be below the maximum so we know if it will dissolve or not. Because if you're insoluble, you won't dissolve whether you're below or above any. There's no limits, right? You just won't dissolve. So on this slide, you need to know, and we're going to have a practice problem in just a little bit, but you need to know what saturated and unsaturated means, what you would expect, like what observations you would expect, and how you can predict if something's saturated or unsaturated, which I do have two practice questions for us. And then in this category, the final vocabulary word is supersaturated. And again, I said it kind of weird because I'm just emphasizing there's super. So saturated means you're at the limit. Unsaturated means you're not saturated, so you're below the limit. Supersaturated means you're better than saturated, like you're above the limit. Now, I want to tell you this is not usually the answer. In this case, the solution is tricked, and so you must have or be described all the steps. So I'm going to tell you what it takes to trick a solution. So a supersaturated solution is a solution that not only contains more solute, but this solute remains dissolved. So here's the difference. In a saturated solution, if you don't trick the solution and you add more than the limit, the extra settles to the bottom. So it doesn't all stay dissolved. In a supersaturated solution, the solution has been tricked. I'll tell you how. And so all of the solute remains dissolved, even the amount that is above the limit. And so it's solution trickery. So what happens is, what you do is you increase the temperature of the solvent. So that allows the solubility limit or the solubility to be greater. So you actually dissolve the solute when the solution is warm. Okay, that will allow more to go into solution. Then you carefully cool that solution, maybe even just by leaving it out. But you carefully cool the solution. And if it's supersaturated, all of the solute will remain dissolved and none of it will come back out of solution, even though you added more than the limit at the cooler temperature. So it's the process of heating it up to raise the limit, then carefully cooling it back down so you lower the limit, but the solution is tricked in that it allows the extra to stay dissolved. Now, these solutions tend to not be very stable, and so they're easily disturbed. And when they're disturbed, it's like, I always think of the solution like saying, I've been tricked. And then it releases all of the extra solute, or another way to think about it is it precipitates out. So then the solid would come back out. And then instead of being supersaturated, now you're just saturated because you're at the limit and the excess is just sitting at the bottom of the container. So the reason, again, that I say it's not usually the answer, you will know right away if it's the answer. Because you can't just say, oh, I added more than the limit, and then say it's supersaturated. That's just saturated by simply adding more than what the limit is. Supersaturated, you'd have to say, I warm up the solution, I add the solute, I carefully cool it back down, and it all remains dissolved. Like, you have to have the process to get a solution supersaturated. So unless you read or see the whole process, don't choose supersaturated. It's just, if it's above the limit, it's just saturated. Now in this image, this is a heat pack, which you might be familiar with. It's supersaturated with sodium acetate. And what happens is you have a supersaturated solution of sodium acetate. And if you look at it, it looks kind of jelly-like, the ones I've seen, but there's no solid in it. But it has like some type of little disc or something. And you trigger that disc, and my imagination, it like wakes the solution up. So then what happens is the solution, instead of being supersaturated, precipitates out the extra, which comes out as the solid. And for sodium acetate, which they make those heat packs from, it's an exothermic process. So as the solid precipitates back out and the solution becomes saturated instead of supersaturated, it releases heat. So that's just a practical example of something that you might have experienced that's supersaturated. So I want to do one more thing in this section, and that is look at how we might use solubility limits and the solubility information to figure out if a solution is saturated or unsaturated, and then what types of observations would we expect given that situation. So right here, this is the solubility. So this tells us what the limit is. So it says 34 grams of KCl will dissolve in 100 grams of water at 20 degrees. Okay, so what this is telling me is this is the max KCl in 100 grams of water. And then the temperature can be important. It says 20 degrees. I know that sometimes in the homework, they will have two solubilities. Like they might show you one at 20 degrees and one at 50 degrees. And then in the problem, it's going to tell you either it's at 20 or 50. And the important thing is here is if your problem's at 50, you need to compare it to the temperature, to the solubility at 50. So you would just need to make sure the temperatures are the same. So here there's two questions. It says, will a solution prepared by adding 32 grams of KCl to 100 grams of water be saturated or unsaturated at 20 degrees? So ours are all at 20 degrees, so that's fine. And so I look, and then the maximum is 34 in 100, and this has 32 in 100. So this is going to be unsaturated. I would like to write this in black. Okay, unsaturated. And I'm going to write a because 32 grams is what we added, is less than the maximum, so which is the 34 grams. So if you're adding anything less than the maximum would be unsaturated. It's not full yet. So it's unsaturated. And our observation and what we would expect is I would expect all the KCl to dissolve. It's really raining at my house, so you might hear it. So I'd expect all the KCl to dissolve because you're unsaturated, so we would expect it all to go away. All right, so that's the first one. Then the second one says, and if you want to pause, I should have mentioned it before, but if you wanted to try to answer before listening, I'm sorry, you could pause on this one. So it said, will a solution preparing by adding 18 grams, okay, so I have 18 grams of KCl to 50 grams of water, be saturated or unsaturated at 20 degrees. So again, all of these are at 20, so that's okay. But what I notice is the 50 grams, this is 1/2 of the 100 grams up here. Right? It's 1/2 of that, which would mean the limit would be 1/2 of 34.